Alright, this is the second skill for today, Thursday, October 12th. The first video was on simplifying radicals. This one is on what we call rationalizing denominators. Rationalizing denominators. Okay, and so what this means is we have a rule in math that says we cannot have either a fraction under a radical or a radical in the denominator. So we can't have two things. We can't have one, a fraction under a radical, and two, we can't have a radical in the denominator. So we got to check for these things, make sure we don't have them. If we do have them, we've got to undo them. We've got to what we call rationalize those denominators. Okay, so we're going to look at two types of kind of rationalizations that you might see. Okay, so number one, we've got the square root of 4 over 81. So here we have a fraction under a radical. We don't like that. So the square root of 4 over 81, that's the same thing as the square root of 4 divided by the square root of 81. Once again, the square root of 4 over 81 is the same thing as the square root of 4 divided by the square root of 81. And then I can go ahead and see, well, the square root of 4, that's 2, and the square root of 81 is 9, so that's 2/9. And hopefully we can see why we're allowed to go from this step to this step. The square root of 4 over 81 means what number times itself is 4 over 81? Well, that would be 2/9. 2/9 times 2/9 is 4 over 81. Okay, number 2. I'll just work this way. Number 2, let's do the square root of 7/16. Okay, so same thing. We write this as the square root of 7 divided by the square root of 16. Well, the square root of 7 I cannot simplify. It doesn't have a perfect square factor, so I leave it as is, but the square root of 16 is 4. So I've rationalized this denominator. No longer do I have a fraction underneath the radical, and nor do I have a radical in the denominator. So I'm good. This is the square root of 7 over 4. But what about this one? The square root of 5/2, 5 over 2. So we write this as the square root of 5 divided by the square root of 2. Square root of 5 cannot be simplified, nor can the square root of 2. So we've got an issue here. So no longer do I have a fraction under the radical, but I now have a radical in the denominator. I've got the square root of 2 in the denominator. That's not okay. So in order to rationalize this denominator, what I'm going to do is multiply by the square root of 2 over the square root of 2. So we multiply both sides by whatever the denominator is. Sorry, I shouldn't say both sides. We multiply both the numerator and the denominator by the denominator over the denominator. Let's see what happens. So the square root of 5 times the square root of 2, that's the square root of 10. And the square root of 2 times the square root of 2, that's the square root of 4. And the square root of 4 is a perfect square. It's 2. So now I'm good. I no longer have that square root in the denominator. It's now a rational number. So let's try another one. That's called rationalizing a denominator. The denominator used to be irrational. It was a square root of 2. Now it's a rational number, 2. So let's do this one, the square root of 6/5. So we know we first need to write this as the square root of 6 over the square root of 5. The square root of 5 is not a perfect square. I can't take the square root of it. So I need to rationalize by multiplying both the numerator and denominator by the square root of 5. So this is the square root of 30 over 5, because the square root of 5 times the square root of 5 is the square root of 25, which simplifies to 5. Okay. So I think we're done. We want to double check to see if we can simplify the square root of 30. Well, is 30 divisible by 4? No. Is it divisible by 9? No. Divisible by 16? No. Okay, yeah, so we're good. Bam. One last one. So this will be square root of 9/8. Okay, that's the square root of 9 over the square root of 8. The square root of 8 is not a perfect square. I can't take the square root of it. So I'm going to go ahead and multiply by the square root of 8 over the square root of 8. That's going to rationalize the denominator. Now the square root of 9 is 3. So this is 3 times the square root of 8 in the numerator. And hopefully we're seeing that the square root of 8 times the square root of 8 is just going to be 8. Because that would be the square root of 64, which is 8. Alright. So we've rationalized the denominator. We no longer have a radical in the denominator. However, I can simplify this square root of 8 because it has a perfect square factor. It can be written as the square root of 4 times the square root of 2. So this would be 3 times square root of 4 is 2 root 2. So this is 6 square root of 2 over 8. Sorry. And finally, I can simplify 6/8 because 6 and 8 have a common factor of 2. So I could write this as 6 divided by 2 is 3, and 8 divided by 2 is 4. So just to recap, to rationalize the denominator, we multiply by the denominator over the denominator. We multiply by the denominator over the denominator. And again, square root of 8, so I need to multiply by square root of 8 over square root of 8. Okay, so that's one type of rationalization that we're going to need to do. Let's look here at another type of problem. So number 6 here. What if we have something like this? 3 divided by 7 plus the square root of 2. Now we have an issue because we have a radical in the denominator. We need to rationalize this denominator. So you might think, alright, let's multiply by the square root of 2 over the square root of 2. But if we do that, let's actually do it. We get 3 root 2 over, now remember, fraction bars act like parentheses. So I need to distribute the square root of 2 to both the 7 and the square root of 2. So this would be 7 square root of 2 plus square root of 2 times the square root of 2. That's the square root of 4, which is 2. I still have an issue. I still have a radical in the denominator. So this is not the method we want to do. This does not work. Multiplying by the radical over the radical did not help in this case where we had two terms. We have to use a different strategy. So this doesn't work. Let's try it again. What we need to do is multiply by what's called the conjugate. The conjugate of the denominator, which simply means we take these two terms but switch the sign in the middle. So 7 minus square root of 2 over 7 minus square root of 2. 7 minus the square root of 2 is the conjugate of 7 plus 2. Let's see what happens now when we multiply. Remember, fraction bars act like parentheses. So I need to distribute the 3, so that's 21 minus 3 root 2 over, and now I have a binomial times a binomial. I have to FOIL. First, outside, 7 times negative square root of 2. Inside, square root of 2 times 7. And last, square root of 2 times negative square root of 2 is the negative square root of 4. Now something interesting happens. The numerator stays as is. I can't combine those terms because a radical is an exponent, and so this term and this term have different exponents. But here in the middle, negative square root of 2 plus square root of 2, that's just 0. Anything plus its opposite is 0. So then I have 49 minus 2, because the square root of 4 is 2. 49 minus 2. So this simplifies to 21 minus 3 root 2 over 47. Okay, so a little bit different when we have two terms, we have to multiply by the conjugate. I think we can do one more. Yeah, let's do one more. So I've got negative 1 divided by 9 plus the square root of 7. Okay, I've got two terms, so I need to multiply by the conjugate. So I simply change this sign. Then I multiply, remembering that fraction bars act like parentheses. So I need to distribute the negative to each term. So that's negative 9 plus square root of 7. And then I need to FOIL down in the denominator. 9 times 9 is 81. 9 times negative square root of 7. 9 times positive square root of 7. And then negative square root, 7 times 7 is 49. So I have negative 9 plus the square root of 7. The middle terms are always going to cancel. You can see that they're opposites, negative and positive. 81 minus 7. That is 74. Yes, 74. There we go. This can't be simplified anymore. So there we have it. Say rationalizing denominators.